link. Let's see whether this works. Okay, wait a sec. You just need to paste the link over on Twitter. Let's see. Just to invite everyone. Yeah. Okay. This works. Wait a sec. Okay. To read that. Cool. Okay, we already have 6 people in the chat room. Cool. So very cool. I open up the top chat and I say, yeah, welcome to this first planetary live stream here on YouTube. I wanted to do that live streaming right for a while now, and finally the weather cleared, and I hope you can hear me. Maybe you can give me something like a feedback about the audio quality. I mean, I can't scream, but because I wake up the neighbors, but maybe you can hear me. Okay, I think that works. Okay, so what are we going to see? Today we want to see some live views of Jupiter and Saturn. They're up right now in the sky. From my location here in mid-Germany, it's quite early in the morning. It's nearly 2 AM and I am a bit exhausted. But the planets are back. The big planets are back, Jupiter and Saturn. Unfortunately, Mars is not in a good position right now, but we have 2 big planets and this is really cool. And so I took my telescope. This is the Skywatcher reflector telescope, the PDS Explorer 150mm aperture. It's a Newtonian telescope, and I pointed the telescope right onto Jupiter, and there it is, right in the center of the frame. Jupiter with its majestic bands and the cloud structures, and we're gonna play around with these settings, and I thought we'd just chit-chat about astronomy and astrophotography just a bit. And later on this night we want to slew to Saturn and see its rings, and if the moon gets up, we can switch to the moon as well. But right now the moon is not there, it's just Jupiter and Saturn, and that's fine for me. Okay, so yeah, hello everyone. Okay, I just need to see, yeah, there's the chat, so that I can follow along as you have some questions. Okay, yeah, this is planetary astrophotography. There are some names around. This is planetary astrophotography. That means that we try to observe the planets or the moon, and this is quite the opposite of normal deep sky astrophotography. So astronomy normally splits up into those 2 parts, the deep sky astrophotography and the planetary astrophotography, and those 2 sub-subjects normally don't have much in common. So, and we are on the second part right now. We are on planetary astrophotography. That means that we try to capture something that is very bright, and actually very, very, very tiny. So the planets are just like star-like if you'd image them with a normal DSLR. And you really need to magnify the image a lot in order to see something. You know what? I really like the details of Jupiter right now. Maybe I just stop talking and try to capture one nice frame. Because why not? Okay, I just captured a small portion of Jupiter. Okay, so the planets are very, very tiny and very, very bright. So in order to capture them, we don't need like the minute-long exposures that we are used to in deep sky astrophotography. We just need very, very short exposures. And on the other hand, we're interested in very, very long focal lengths in order to magnify the image. And we don't need a camera with a very, very huge sensor as an astrophotographer in deep sky astrophotography, but we only need a very tiny sensor because the planets are so tiny and we are not interested in all the blackness around that. And yeah, planetary astrophotography then is all about seeing and air quality. So the moon does not really interest us. Light pollution does not really interest us. It's all about the quality of the air, the calmness of the air, what we call the seeing. And yeah, it's because the atmosphere of the Earth acts just like another optical component. It's just like a lens. Problem is, that would be fine, but problem is that the atmosphere is wobbling around, and in order to capture a great image of a planet, you need the atmosphere to be as still as possible. This is not a problem with a wide field telescope, like say 300 or 400 millimeter focal length for deep sky astrophotography if you try to capture like giant nebula and cloud structures. But as you increase the focal length, seeing becomes more and more of a concern for us planetary astrophotographers. And so we need the air to be as calm as possible. And in order to do so, we try to maximize the frame rate, not the exposure length, but the frame rate in which we capture the planet. And then we don't take, say, 1 or 2 images, but we take a video format, a video file of thousands or 10,000s of frames, and then let the computer decide which frames of that are best, and let's say take the best 10% and stack those together. And yeah, that was what I did a few seconds ago. I captured a video frame of Jupiter to stack that later. So that was that. Here on Jupiter you can see the main belt, the orange belt over there, and you kind of can see some additional bandings on the top and on the bottom. I don't see the red spot right now. It might be there on the left hand side. I'm not quite sure about that. So seeing is not perfect. And you can see the planet is wobbling around. And this is exactly what I meant with atmosphere distortion. So this is the air between us and Jupiter wobbling and bending and stretching the light, which is actually a cool thing to think about. So, but this is also the problem with astrophotography for us, for planetary astrophotography. this bending and stretching of the air around the planets. All right, like 6 people in the stream. Welcome everyone. We are doing planetary astrophotography this night. Actually, it is this night for me. It's 2 AM in the morning. Look at that. Quite a few fellows retweeted my tweet on Twitter. Thank you very much. Maybe we are able to reach out to even more people seeing this live stream and enjoying the sight of the planets. We are about to imaging Jupiter and Saturn, and what you see right now is a live view through my reflector Newtonian telescope at Jupiter, our biggest planet in the solar system, with its band structures. Yeah, quite a cool thing to do. Head over to the chat. No, there's nothing going on there right now, but hey people, hello everyone. Yeah, cool thing. Wait a sec. I'll be back in a second. So there I am back again. Is the audio quality okay? Can you hear me? Is there any problems with audio or concerning the video? You can give me a heads up in the chat. And I'm just looking at these specs. We have like 10 people in the chat. Very cool. Yeah. Okay. So this is Jupiter you're looking at. Very beautiful planet. There are 2 teams in astrophotography and planetary astrophotography. There's Team Jupiter and there's Team Saturn. And actually, I don't know in which team I belong. Maybe I'm Team Mars. Mars is such a cool planet as well. A bit harder to image because it's most times of the year it's a bit smaller and just in opposition as we had last year. Or the beginning of this year? No, last year, yeah. In the opposition at last year when the planet is closest to Earth, yeah, then Mars was bright and shiny as well. But normally it's much easier to image Jupiter and Saturn. But both planets are amazing, and I love imaging them whenever it's possible. And right now they're back in the sky for me in the northern hemisphere. It's 2 AM in the morning, but looking at this beautiful planet is just worth getting up or staying up until now. Great thing to do. Okay, hi everyone in the chat. Feel free to ask questions, feel free to comment things or just to chat along. And oh yeah, you see that? Now the planet gets really wobbly. There's some wind turbulences up in the atmosphere that just disturbs the image. And if you look at Jupiter closely, you have moments where Jupiter appears very sharp and crisp, and you can make out some details. And there are other moments, like fractions of a second later, where everything is just blurred. And this is the problem we are facing with planetary astrophotography. So the air is moving all the time. And we try to capture as many frames as possible, like 50 images per second, or 100 images per second, or 150 images per second. That depends on the shutter speed, or the exposure time, and the quality of your camera, and the quality of your computer. Excuse me. And then we want to pick the images that are very sharp. And if you look very closely, you can even see regions being sharp and other regions being not as sharp on the same time. So what we then do is tell the computer to split the image into pieces, determine which parts are the sharpest, and then stitch them back together. But we do that in post-processing. Well, that's all right. Okay, hello everyone. More than 10 people in the chat. Cool. Very cool. I hope you enjoy the magnificent, the beautiful view of Jupiter right now. We can tweak the settings a bit. You see here we're at 13 milliseconds exposure time, and right now with this exposure time we only can see the planet and its cloud structures. And in order to see the moons of Jupiter, we need to increase the exposure time so that the relatively dark moons appear on the camera sensor. But on the other hand, if we do that, then the planet gets really blurred out. Yeah, but there they are. These are the planets of Jupiter, namely the innermost planet right here is Io. The next planet is Europa, and the third planet is Ganymede, or Ganymede. So Ganymede, I think. Okay, and yeah, this is so cool. So I mean, Io, the innermost planet from our perspective, actually Io is quite near to Jupiter, and Io is a hot and volcanic moon. That surprised the astronomers when they found out about that. The reason is, I think, as long as I'm concerned, that Io is not on a perfect circular orbit around Jupiter, but on a slightly elliptical orbit. And so the tidal forces on Io, like squish and pulse on Io all the time, the difference in gravity for the side facing Jupiter and the side not facing Jupiter on this elliptical path is pushing and squeezing Io around, and therefore producing heat in the middle, the core. And so there is molten rock inside Io and volcanic activity, and that really surprised the astronomers when they found out about that. And the surface of Io is hence very young, and it's very colorful because all the elements of the inner crust are spit out onto the surface, and it looks really cool. But it's a hell of a moon. You never want to walk on that because there's molten rock everywhere, and I think it's maybe very dangerous to walk there. Yeah. The next planet, the second one from our perspective, the middle one, so to say, is Europa. And Europa is a very cool moon as well. So you need to think as of Europa as a frozen ice ball. So water ice is quite common as an element in the outer solar system, and Europa may have a solid rock core, but the exterior is like 100% water. And in this case, because it's very freaking cold out there, it's all frozen. But for the same reason, that Io has volcanic activity, Europa does not circle on a perfect circle around Jupiter as well, but on a slightly elliptical orbit, and so there are tidal forces as well, creating heat inside Europa, creating maybe a liquid ocean underneath the ice crust, which is a really fancy thing if you think about that. And for that matter, making Europa one of the possible candidates for hosting life within our solar system outside Earth. And yeah, we're looking at Europa right now, and this is a cool thing, I think. Yeah. So the hope is that within this area of liquid water underneath the ice crust, that there is maybe volcanic activity on the ocean's floor, and a black smoker. I don't know whether you heard about them. These are like mini underwater volcans spitting out hot water and minerals and stuff like that. And we have like a very rich environment of life around those black smokers here on Earth, and that might be true for Europa as well. That would be super cool, but we need to go there, dig through or melt through the ice with a space probe, which is a bit complicated. It's a tricky thing to do, and yeah, then have a look. But I think a mission like that is like far ahead. It's not that we're going there like tomorrow. Okay. Okay. We have 10 people watching. Hello everyone. Great to have you around. The average view time is 3 minutes. Okay. whatever she'll tell me that. I don't know. Shall it be like that? Yeah, and the outermost planet moon is Ganymede, but I don't know much about Ganymede. I need to be honest about that. And so yeah, those are the moons, and we can like can decrease the exposure time again. And oh no, do you know what? We just capture a few frames of that, because in those cool images you see of planets where the planet is right visible and the moons are visible as well, those are normally composited images. So you have two exposures, one for the planet, one for the moons, and then you stitch them together in post-processing, because you can't expose both planet and moons in a cool manner. That's just not possible. And yeah, there I go and just fetch a few frames of the moon so that I can stack them in post-processing and stitch them to the image of Jupiter afterwards. Okay. If you have any questions, or if you like to chat around, just use the chat. I can try to answer some questions, or you just talk with each other. Okay, so let me see. Yeah, the collection of the frames is nearly done. I told the program to fetch 200 frames just for the moons. We don't have any surface details of the moon, so it's not that important. It's just to get rid of the worst atmospherical artifacts. Okay. Yeah, welcome everyone. Welcome everyone in the chat. This is us looking at Jupiter. Right now it's totally overexposed because we want to capture the moons, and the moons are just a bit dimmer, so we need to crank up the exposure time. And yeah, just to make the moons visible. And we're nearly done imaging the moons. 5 frames to go. And then we can decrease the exposure time again. Something like that. Yeah. And now you can see Jupiter in all its beauty again, with the bandings. And that looks much more, yeah. This is Jupiter as we know. Yeah, taking images of Jupiter means that we point a telescope, obviously, at the planet with a long focal length and a camera that is able to capture a high frame rate. And then what we do, as I said before, we capture as many frames as possible per second to get rid of the atmospheric aberrations and stack that in post-processing. And yeah, and thus we don't take a long, like minute-long exposure. We don't need to do that because Jupiter is just so bright, like any other planets besides maybe Pluto. And we take a movie file. Yeah, in my example, it's a .mov file. No, an AV file. Excuse me. An AV file. It's uncompressed, so that we can work with the data afterwards. And we take a movie of thousands of frames or 10,000s of frames and stack that. And thing is, that takes time, obviously. Say for Jupiter or Saturn, you take like a minute or 2 minutes of data with the highest frame rate possible and use that data to stack that. The thing with Jupiter is that this planet rotates very, very, very fast. And so you don't have like more than 2 minutes at one time to image the planet continuously, because after 2 minutes the rotation of Jupiter will, if you stack the image afterwards in post-processing, will blur the edges of the planet, because you can actually see the rotation of Jupiter. I think, right out of my head, the rotation period of Jupiter is something like 9 hours. Remember that? The tiny dot we sometimes see under the big red belt. This is the big red dot. This is a storm in the upper atmospheres of Jupiter, and that this storm alone is bigger than Earth. And this planet is massive. I mean, really massive. It's just so tiny for us because it's so far away, but this planet is gigantic. It's the biggest planet in our solar system. And nevertheless, the rotation period of Jupiter is just 9 hours, so it's spinning really, really, really fast. And this like limits our exposure to something like 2 minutes. So, and if you go longer, then the rotation period will smear and blur the outer areas of the planet. And this is it's a cool thing to think about. Yeah, oh, it looks so beautiful. I really like that site. Okay. Hello everyone in the chat. I hope you enjoy the view of Jupiter. We're imaging the biggest planet of our solar system right now. Yeah, and I just try to chat along with you. You can use the chat to ask me questions anytime, or make suggestions what we're gonna do next. We have a few more things to do this evening, or this morning. It's early in the morning, past 2 a.m. in the morning. We want to image Saturn as well, the second biggest planet in our solar system, with this beautiful ring structures, and we want to use a Barlow lens as well. This is something like that. This is you could call it a magnifier. Yeah, it's an additional lensing that increases our focal length effectively. So that comes with downsides sides, because there's no free lunch in physics. But technically it increases our focal length. And this time it's a 3 times Barlow, so it's tripling our focal length from 750 millimeter focal length, this is what I'm using right now, to somewhat over 2 2.2 meters, I think. And this will magnify the planet a lot. And yeah, we can try that in a minute. Downside is that any aberration that occurred without a Barlow will be magnified as well. So if you have a blurry image, it will be even blurrier. If you have like other artifacts or imperfections within the scope, that is going to be magnified as well. And the lens itself, so the Barlow lens, will add additional errors or imperfections if it's not a very high quality Barlow lens, which this is. It's a cheaper one. It's from Omegon, a 3 times achromatic Barlow lens. It's multi-coated, yes, but this lens is not perfect. We like that. But either way, I took some cool images with that Barlow lens. Yeah. Okay, hi everyone. Okay. I'm back in a second. Okay. Yeah, hi everyone. How is it going in the chat? Okay. Yeah. As you see, we're imaging Jupiter, the biggest planet in our solar system, and we're going to use a Barlow lens on that beauty just to increase the details we can see. But before we do that, you see here in my program there's a sign called capture area 640 to 480. So because planets are so tiny, when we image them with a long focal length, we use cameras with a very, very small sensor size because we are not interested in all the blackness around it, we're just interested in the planets itself. And having such a camera with a small sensor does help because you don't generate as much data, waste all the black data around it. But you can even crop down the image even further from, I think my camera has, the full resolution is like 1280 times 960. So I crop it down to 640 to 480. And what you see right now is like 200% zoom. This is the planet's actual size on the sensor chip right now. And we're capturing a smaller portion of the sensor, but we gain a higher frame rate by doing that. And this is actually quite helpful because we want the frame rate of our capture for our image sequence to be as high as possible, and I just grab another 2000 frames because I really like how Jupiter appears right now. Okay, if we after this we're gonna try and add the additional Barlow lens to even increase the magnification of Jupiter. Okay. Something like that. Okay, so it's done. For me that means I add like a crossing and make sure that Jupiter is like dead center. Something like that. I crank up the gain and the exposure time a bit. Okay, so now I need some time to add the Barlow lens, and you can enjoy the sight of the moons of Jupiter. I add the Barlow and we shall see whether this works. Well, like always, now the planet is lost. Lost forever. We need to find it again. Okay, that was easy. Sometimes it's quite difficult to find the planet again. This time we played safe. Okay. There is, right out of the box, you see Jupiter is much bigger. Now, thing is, we need to refocus, and focus is one of the hardest thing in astrophotography. Okay. The bitrate of the audio stream seems to drop. Can you hear me? Can you hear me? And you could give me a feedback in the chat. Okay. So, okay. Done. Because YouTube is telling me that my sound bitrate is too low. But if you can hear me, that is great. Thanks, Tim. Thanks. Dinergency. I don't know how to call your name. Okay. You're chatting along in the chat. That's great. Okay. What is your favorite nebula or galaxy? The Andromeda galaxy is quite a marvelous thing to image. Okay, I need to find focus again, so I need to take the laptop with me because this is the most easy thing to do for me. Just to stand next to the camera. And then fiddling with the focus. There you can see it's quite difficult. And we need to decrease the gain, crop the image, and then find focus. And finding a good focus point is always a bit tricky. So here I'm trying really hard. Optimal position. That looks promising. I think we go with that. That actually looks quite good. So because problem is, for my location, oh look at that. We need to capture a few frames with that. Because for my location the planets are always a bit low in the sky. And thus the atmospheric effects are very, very large. This always troubles you if you try to find like good focus or something like that. It's quite a hard thing to do. Okay. Oh, you know what? Stop capturing. I did a mistake. We'll crank up the gain a bit. This looks good. Okay. You need to find like sweet spots for the planet. And for all the settings in SharpCap. I'm using SharpCap, and with SharpCap you can set up the exposure time and the, let's say, the sensitivity of the camera. This looks good. And you need to find some sort of sweet spot in order to take a cool image. Yeah, this sometimes you try to fiddle around with that. Okay. You're talking about filters? Yeah, I don't use any filter. This is just raw RGB, and you can use like infrared cut filters, and some people use moon filters, but I don't use anything like that. It's just raw color coming in my telescope. And I don't know, I like the results so far, so I'm just going with that. Okay, so you know what? I really like that view of Jupiter. Just to be sure, I'm taking a second round of images, because right away in the live view you can see like cloud structures, and it's normally a good thing to do if you see something like that. Okay, we're synced. And if we're done with that, we're capturing at 29 frames per second, and we're gonna capture a few moons of Jupiter close up right now, and then I think, if you don't mind, we slew over to Saturn. Oh, excuse me. Yeah. Right. Yeah. Observing Jupiter visually, this can be a bright thing to do, like with the moon. Yeah, and so you're totally right. You can use a moon filter, and just to decrease the brightness, because it's a funny thing. If I show someone the side of the moon through my telescope, without any filters, and it has 15 centimeter of aperture, and it's like blinding bright. It's so bright, and you look into the scope like, what? What's going on there? And you're totally right, Tom. Then a filter to decrease the brightness is a good thing to do. Okay, I think we increase the exposure time. But you know what? Being so close, we can only see the innermost moon. This is Io. Well, we captured Io already, so I think that's that. We're done here. We can decrease the exposure time again. We won't see anything new right here. And oh boys, I really love this side of Jupiter through my telescope. And okay, now if you don't mind, I'd really love searching. Look at that. Searching Saturn. That would be a cool thing. Yeah. Okay. So let me open up Stellarium. I use Stellarium in order to control everything. And let's hope that we're current object, Saturn, Slew. My hope is that we're not too far off. Oh boy, I like this mount. Look at that. Do you see it? Do you see that? This is the difference between Jupiter and Saturn. Okay, Jupiter is like bright, shiny bright, okay? And Saturn is a bit dimmer, but we're spot on. I love that. The Skywatcher EQ6R Pro mount is just a superb mount, and the pointing accuracy is over the top. I can't emphasize that enough. Okay, so let's okay, look at that. Okay, folks, you know what? This side of Jupiter, of Saturn, I, I need a smile. This side of Saturn, this is what brought me into astrophotography in the first place. I mean, look at that. Maybe in the beginning I said I don't know whether I'm Team Jupiter or Team Saturn. I mean, Jupiter is such a cool planet. True, but Saturn with its rings, it's a marble in the sky. Look at that. It's so cool. Got a NEQ6 Pro. Yeah, it's agreeing. This mount is just superb. I had the EQ3 Pro mount. This is the small brother, and this is it's a fairly lightweight mount. It's okay-ish. It's okay. It's cool. No, I had a lot of fun with this mount, but the EQ6R Pro is just it's heavy. It's rigid. This is a cool mount. You can work with this. I mean, you saw that, the pointing accuracy, even using a tiny small sensor, and even using the 3x Barlow lens, that means 2.2 meters of focal length, it pointed right straight on the screen. It is just amazing. Wow, is in opposition on August the 2nd. Yeah, okay, so planets do orbit the sun, no shit, and so does Earth. And there's a time in the year, not once every year, but for the very, very distant planets, it's roughly once every year, because the Earth does rotate around the sun much faster than Jupiter and Saturn, and roughly every year It's quite a bit longer than the. So there's a point in the year where like Sun, Earth, and Jupiter or Saturn, when they align, and then the planets are closest. You can observe them at midnight. They're very high in the sky, and they appear brightest. And this is the moment to choose if you try to capture a really good image of the planets. Okay, there's a question in the. Yeah, Tim. I will watch Saturn and Jupiter for a month as well. JS is asking what the focal length of your scope. I'm using a Skywatcher Newtonian telescope, the EQ, the Skywatcher Explorer. The focal length is a 750 millimeter focal length. It's a Newtonian telescope, and it's kind of an all-rounder. You can do all sorts of things with it. This is why I love the scope so much. The focal length is short enough for most nebula. Sometimes it's a bit too long to capture the bigger stuff in the sky in one frame. Like the Andromeda Galaxy, it's cropped. I would need like 0.5 times reducer, and this is not a good thing to do with a Newtonian telescope. And yeah, but if you triple the focal length with a Barlow lens, then you're up to 2.2 meters of focal length, and you can image the planets. Okay-ish. Okay, it's not. There are telescopes with a native focal length of 2.5 meters, and if you double or triple that, you're even close up. But for me, it's okay. Look at that. I mean, look at that sight. It's just amazing. So, okay, first thing we do is we capture a short. No, we increase the exposure time. Let's do that. Or the gain. 44. Remember 44. 44. Was it like that? Yeah. 130. 130. Okay. So here we have the moons. We're like taking a few frames like that. It's taking us ages. Okay, you see the bright moons over there. This is Titan up there. Tom, that highly depends on what you're gonna do. What do you like to do? If you do astrophotography with nebula, then it's another task, like doing planetary imaging. It highly depends on the subject. What do you love? What do you like to do? What do you like to see? So there's no general answer to what scope do you is best. There's no best scope. Okay. 130p. What if I go and start tracking? Yeah, the most important thing to upgrade is the mount. Well, you want to go into deep sky astrophotography, then the first thing you need to buy is a mount. The mount, a solid mount, is the most expensive thing to buy, and yeah, exactly. This is just expensive. Okay, but I did it the hard way. I bought a Skywatcher EQ3 Pro. That was okay. It's I think $350. Okay, and I put my Skywatcher Explorer, the 750mm Newtonian reflector onto it, and that was too heavy for the mount. Okay, and so doing those long exposure shots, you really need to nail the tracking, and if the mount is not capable enough, then you will have shaky stars and elongated stars and imperfect tracking, and this is just not a fun thing to do. Okay, you don't want to do that. So if you want to have an advice, if you want to image nebula, yeah, then do it like like Tim states. Do it like Astro Backyard. Trevor uses very short scopes. So use if you can't afford a very rigid and very big mount, then use a short scope. So a tiny refractor, focal length like 300, 400mm. Those scopes are very forgiving, and you can put them on smaller mounts, and so tracking doesn't bother you this much. This is a first step to go, or just use a DSLR and a camera lens. Yeah, and then the EQ3 Pro mount is more than enough for that. Yeah, Chuck and all the YouTubers out there, they are so amazing. I learned so much great stuff from them. It's just cool. Okay, we just stopped the capturing here with Saturn, because boys, we're here for Saturn. Okay, 44 was our setting. And we're gonna crop the image. Look at that. Yeah, Tom, if you have a second-hand DSLR, then use that DSLR to take images of nebula in the night sky. You can do that. This is a fair thing to do. Yeah, Astrobist is a cool guy too. Yeah, there are so many great tutorials out there. And I love that side of Saturn. I'm gonna increase this even further. Look at that. And now we're gonna capture 2000 frames of Saturn. I mean, seeing is not great, okay? But right out of the box, you can see the Cassini division, and seeing the Cassini division is always a great thing. Because the rings around Saturn, I'm using SharpCap. I highly advise you to download SharpCap. It's free. The advanced settings require the Pro version, and I don't know, this is like 20 bucks or something like that, and it's really good. SharpCap is a great tool, especially for me for polar aligning. I do polar align with SharpCap, and it's the workflow is like perfect. You point the telescope north, you open SharpCap, and I do load the images of the of my guide cam, and then you rotate the scope, and SharpCap will tell you how to adjust the mount so that you are perfectly spot on concerning your polar alignment. And this is just, it works like flawless. It's really good. yeah. Astrobiscuit, he's cool guy. $9 per year. I think I bought it for a fixed price. Well, I don't know. I never polar align my telescope. Yeah, Tom, but if you do visual astronomy, who cares? This is just the thing. But if you want to do astrophotography, deep sky astrophotography, if you want to image like 5 minutes, 10 minutes for one image, you really need to nail the polar alignment. Otherwise, it just won't work. No, polar alignment is a thing for German equatorial mounts. Okay. Okay. We are still imaging because the frame rate is down to 6.5 frames per image. This is because my gain is quite low, and so the exposure time is a tenth of a second, and naturally then the frame rate will incidentally drop. Okay. Yeah. JS, you're right. If you do deep sky astrophotography tracking and guiding, that means auto guiding, and polar alignment is a thing to do. You know what, Tom? But tabletop telescopes are a cool thing as well. They're just a totally different thing. I like them. Okay. We're nearly done with Saturn here. Yeah, JS, this is what I mean, I'm lazy. I'm just using a color camera, okay? But if you want to get the best possible shots of a planet JS, then you need to use a monochrome camera. This is because the monochrome cameras are much more sensitive, and hence you can even reduce the exposure time and increase the frame rate even further. Okay, and then you take a bunch of filters, RGB and L. Yeah, normally you do rRGB, so you take the red channel as a luminance layer, whatever, but you take the different layers and stack them on top. But keep in mind, please, if you do that on Jupiter, because Jupiter is rotating so fast, you need to shorten the amount of time you spend with each filter. So you're just like 30 seconds on red, 30 seconds on green, 30 seconds on blue. Because if you're like 2 minutes on each filter, then within the last filter, Jupiter will have rotated so much that the edges are smeary and blurry. Yeah. And so if you want to take very crisp and clear images of the planets, you would do monochrome camera with rRGB or RGB and L, or RGB and RAW, nothing, or IR cut filter, something like that. So just search Dylan. Dylan did a great tutorial about that. He showed like when Jupiter was in opposition last year or the year before that, he took an amazing image of Jupiter and he used this monochrome camera. Yeah, I mean, why not? If you have the RGB filters, then you can, depending on your scope, you can try planets. That's a fair thing. Oh, look at that. Look at that. I really love the sight of Saturn. It's so amazing. Let's crank up the gain a bit to decrease the exposure time. Makes the planet appear very pixely, but we can increase the frame rate up to 20. Oh, look at the atmospheric the atmospheric effects now. Really hitting us. But either way, it's so beautiful. I really love it. 10 people in the chat. It's like 3 a.m. in the morning for me. Yeah, Tom, really. To be there in person, to be in one on Saturn's moons, and you need to imagine that. It's the same thing with Jupiter. If you stand on a moon of Jupiter or on a moon of Saturn, same thing. And just imagine the sight. Okay, so those moons, because they are so close to such a big planet, they are tidally locked, just like our moon is. So they are always facing the same side towards the planet. And if you stand there on the right place on the moon, and like the whole gas giant fills the sky, that must be such an amazing view. Yeah. 11 a.m. here, yeah, hey Dave, yeah, not for me. It's in the middle of the night. I need to sleep. Uh, yeah, Tom, but to see it in person, like really, if you're there, that would be so cool. Yeah, jaw dropping, really. Yeah, Tim, that would be cool. Tourist trips there, I'd be in like instantly because that would be so cool. And you know what? As much as SpaceX gets bad news for putting up their hundreds and thousands of satellites, ruining our our long exposure image spot, developing what the neighbors are up, developing the Starship, and maybe being able to put people into space, like not only a few astronauts, but hundreds or thousands. That's a cool thing to do. Tom, an elevator to space this is a really complicated thing to do, and yeah, Blue Origin can dream of doing so, but there's no current technology to build a space elevator because the material for the space elevator lane, the main cable, does not exist. So um, we have materials that would give us the needed strength, but only in millimeter or sub-millimeter length, and we need like 10,000s of kilometers. And no, Tom, it's not possible to stand on the rings of Saturn because the rings of Saturn are made out of ice and dust, and they're very thin, like meters or kilometers thick, but it's nothing solid, for one thing, and the second thing is because they are so undense, they don't have gravity. Okay, so you're just floating around Saturn with the rings or not. Yeah, David, it's the same thing for me. Yeah, Starlink has huge potential benefits for humanity. I mean, the internet connectivity all over the world. Like you're in the middle of the desert, or you're in a rural area in Russia or somewhere else, and you just snap with a finger and have broadband internet connectivity. This is a sci-fi dream come true. Like the global internet spheres of the sci-fi books. This is something like that, okay? But the damage to the night sky is intense as well. Okay. No question about that. I really love that side of Saturn. Look at that, boys. So cool. And the seeing got worse. With Saturn slowly. I try to spot it with my naked eye. It's over there. The brightness difference between Saturn and Jupiter is just so immense. Yeah, but it's dropping in the night sky, and if you look closely, you see that the upper edge of Saturn is slightly reddish, bluish, and the lower edge is slightly reddish, and this is the color diffraction. So light with different colors gets band differently in the atmosphere. So the colors do split up a bit. That makes our image a bit smurry. This is a perfect thing if you do planetary in mono, RGB, because then the images are more sharp, and then recombine them afterwards, because you minimize the effect of this effect. Yeah, you still discuss the possibility of standing on Saturn's rings, which would be a cool thing to do. I totally agree. Okay, I take one more video file of Saturn just because I love it so much. The site is incredible, even though it's starting to wobble around quite a bit. Maybe we go back to Jupiter, and what shall I say? The moon is rising as well, so we can try to sneak some cool shots of the moon as well. But right now it's behind the tree, so we can't go there right now. We can go back to Jupiter. Tim? Yes, I use a Newtonian telescope, the Skywatcher PDS Explorer. You can Google that. It's a Newtonian telescope. It has a main mirror, 15 centimeter diameter, and 750 millimeter focal length. Bortle 6 here. I'm Bortle 5 to Bortle 6, like on the edge of a town. And light pollution is a thing here. That's certainly true. Light pollution is always a factor in astrophotography, not so much though in moon photography or planetary astroimaging. So because the planets are so bright, and the region of the sky you image is so tiny, you don't really care about every other facts other than the air movement, the seeing. You love the moon. Yeah, the moon is just such a beautiful sight. It doesn't really fit on one frame with my telescope, but we can image it either way. But right now it's still hidden. You know what? I really love to see the moon of Saturn one more time. Oh, look at that. Look how many moons you can see. This is pretty cool. I need to ask Stellarium how those moons are called. So, I don't know that. Okay, there they are. The uppermost moon is Titan. Titan is a fantastic moon. Titan has an atmosphere, and a rich one too, a very dense one. And okay. A very dense one too, and but Titan is very, very cold, so it's quite interesting. It's so cold, and the air pressure is so high that ice is like hard rock on the surface. So water only exists as rock solid ice, and it's the equivalent of our soil. And Titan does have open fluids on the surface. It's not water. It's not water, but it's liquid methane and ethane, and it's so cool that there are oceans on the surface of Saturn, of Saturn's moon Titan. And you have rain, and you have rivers and riverbeds and lakes, and it's just not like rocks and water, but it's water ice and liquid methane, and this is a cool thing. Hi Arvind. Yeah, and the other moons, and I think Titan was once captured because the orbit of Titan, you see that is very it's very like over Saturn, so to say. The orbit is a bit off, so I think Titan was captured. Then the moon right below Saturn on the lower left hand side, this is Dione. Then there's Tethys right on the left hand side, and between Tethys and Titan there's Rhea, and I really love this thing. Okay, Arvind has an 8-inch Newtonian. Yeah, I have a 6-inch Newtonian. An 8-inch is quite a bit bigger, and a 3 times Barlow, and he claims to view Jupiter and Saturn quite decently. Yeah, I believe that. You have the ICE-A 120 MCS color camera, and this is what I use. This is the same camera for me here. It's like 150 bucks, something like that. Okay, we want to decrease the exposure time again so that we can visit our beloved planet again. Look at that. Ooh, I love it. Hi, hi, hi. Hi, Eleni. Elaine, excuse me. Hi, everyone in the chat. I hope you're having a good time. I don't know, do you want to stay on Saturn or do we want to switch back on Jupiter? Because really, I'd like to see whether the rings of Jupiter did appear. I don't know, what's wrong with me? The great red spot on Jupiter. That would be so cool. Just what? No, it's just emerging. So. Okay. I think I will give Jupiter another try. Bye bye. Jupiter's your vote, Tim. I think I'm Team Jupiter right now as well. Elaine, you're picking up your Rasa 8. Oh, I don't say I hate you, but I'm dreaming of owning a Rasa myself. That would be so cool. Okay, we are slewing right back to Jupiter. This is what I meant with pointing accuracy. This mount is exceptionally great. Oh, look at that, boys and girls. Look at that. I instantly need to capture a. Wow. Boys and girls, this is a sight. Oh, I love it. I love it. I really can't decide whether I'm Team Jupiter or Team Saturn. Look at that. It's amazing. Excuse me, it's amazing. This is just great. And the seeing is really good as well. I mean, look at that. You can actually see the red dot and the banding of Jupiter. It's so beautiful. Awesome. I love it. Just for me, I'm so excited. E80 doublet refractor. David, yeah, well, that's a great scope as well. Julian asked whether anyone has any idea. Oh, okay, Jim. Anyone has any idea of the Galileo's telescope specs? This is a cool question to ask. I really don't know, but that would be great. David, I'm using a Skywatcher EQ6R Pro mount. This mount is superb. I really love it. Yes, boys and girls, this is a great shot of Jupiter. Seeing is okay. Great. Just to be lucky, another 2000 frames. It's oh, you know, those sights. When you look at the planets like this, if you see the banding and the surface details of the planets like this is why I stay up late. I mean, it's like 3 a.m. in the morning right here, but it's worth every second. It's just such an incredible image. I really can't believe it. I look up in the sky and there's just a tiny dot over there. And I look on my screen and it's significant. It's so cool. That depends on your frame rate, David. How long does it take to record 2000 frames? It depends on the frame rate. And we're up to 44 millisecond exposures. And so that gives me, you can calculate that, how many frames fit in 1 second. And that gives me something like 20, 30 frames per second. And the ETA is something like 3 minutes. And you shouldn't go over 3 minutes with Jupiter. Like 4 minutes is the max. Because if you image Jupiter for too long, you will get rotation artifacts. Because Jupiter is just rotating so quickly. Yeah, okay, so 2000 frames are done. They are stored inside my AV file, and we can process this later on. But you know what? Maybe I stack one file just for you folks. Let me see. You can marvel on Jupiter, and I stack the latest just to give you an idea of what stacking can do. I need a second. It's analyzing the frames. We're placing a grid. It can be smaller. Okay, something like that. Sharpen, blend, no drizzle. Go ahead. And then I can show you the first unedited and very raw result. Whatsoever. Just what we achieved right now. We 10 people here in the chat. It's a good thing to do. I like this this astrophotography live session thing. It's a cool thing. Okay, you know what? 20 sharpened. Cool. Yeah, why not? Okay, wait a second. I need to add a image layer. And I call it result. And I need to add the result like that. Oopsie. Excuse me. I'm back in a sec. JPEG. Save it as a JPEG file. You see, this is the first rough edit of Jupiter. I just tossed it into Deep Sky Stacker and didn't finalize all settings. It's just what a stacked image would look like. Yeah, that's a cool thing. I like it. It's not the best image I took, but it's really cool. I like it. I like it, I like it, I like it. Okay, Elaine has a question. The camera of the Rasa's in the front. And you try to take dark frames. Yeah. What camera do you have, Elaine? I think... Okay, but this is not the live stream. This is the live view of Jupiter. So we're back at live. Astro imaging, yeah. Okay, Elaine, if you have a dedicated astro camera, then you can set the temperature to the temperature you image, and then you're able to take a, what is that? It's not a filter. It's like you close the camera, and then you take some images, I guess. I never done that because I use a DSLR camera with my Newtonian telescope, and I just close the telescope, and that's just fine. Just need to Google that camera just to make sure I'm on the right side. Yeah, I mean, can you detach the camera from the telescope? Just clip the cap in front of the camera, set the camera to the settings you used, set the temperature to the temperature you imaged, and then you should be good to go. I guess. I mean, if anyone in the chat has a better experience with that, then please help Elaine out. But that would be the way I go. So it's the same thing with DSLR lenses, because quite a few folks tend to detach their DSLR, clip the cap in front of it, and then put it in the fridge and set the temperature of the fridge to different temperatures, and then take darks at different temperature levels and store them in a dark library. And this is actually a very handy thing to do. And then you have darks for different temperatures, and you can just reuse them, like not forever, but for a certain amount of time. And while we're talking, we're talking, I'm just taking another bunch of images. No, Toshal, I started astrophotography with my telescope, so I was really in love with seeing Saturn and the planets, and then I quickly got into deep space astrophotography, and I used an ancient DSLR for that, and then I bought a used DSLR on eBay and astro-modified it. And now I use this astro-modified DSLR, and in a future point I will switch to a dedicated astro imaging camera, just because they are so much more satisfying to use. But right up until now, I really love my astro-modified DSLR. It's a great thing to use, and I use my Newtonian telescope with that in combination. I need a additional field flattener, but as I'm shooting in raw RGB, I don't need any other filters, and I will start using HA filters soon, because that can really enhance your images. And since I was late on stream, that we haven't done. No, David, we have not imaged the moon yet, but unfortunately, the moon decided to just right now stand behind a tree. So we need to wait until the moon is visible from our perspective again. Unfortunately, it's a very big tree. Yeah. What shall I say? Okay, we imaged another image. I try to gain 29. Yeah, there's no other moon other than Europa visible from our perspective. So on the very left-hand side of the screen, there you see Europa. No, it's Io. Excuse me, it's Io. The innermost moon of the Galilean moons, like that. But we're not that much interested in the moons. Yeah, it's shy. I don't know, because the moon would be such a lovely thing to image, but not now, not right now, because the sight of Jupiter is just too cool and too amazing to give it away, just like that. Okay, folks. I don't know. David, I need to go to bed. Going for low shadow. Yeah. Thanks, Hoax. Yeah, Jupiter is cool. The shadows on the moon, yeah, that would be a cool thing to image as well. So maybe, David, the deal is like that. We wait until the moon does pass the tree, and we image the moon for just a little while, and then I need some sleep, because it's like then will be 4 a.m. in the morning, and yeah, everyday life is back. Well, it's a fun thing to do. Look at that. Look at Jupiter. I hope you can see that. It rotates. That means for me another 2000 frames. When we started to image the big red dot was on the left-hand side of Jupiter, and now it's nearly in the middle. It's really cool. So, may I ask you a question? From which countries are you watching this live stream right now? I'm just curious. Where are you from? And what's the time right now where you live? That would be interesting to know as well. This side is so cool, Jupiter. I love it. It's so great. Look at that. US 9 p.m. Yeah. From Australia, hey! And David is from Australia as well. Hi. Yeah. From India. Cool, hello. It's 11 a.m. Yeah, that's USA 6 p.m. India 6 a.m. Tennessee 9 p.m. I'm in Germany and it's 3 a.m. right now, right here. Okay. Let me see whether I can sharpen that Jupiter even more. Stretch. Okay, you know what? I can show you the rough sharpened version of Jupiter. Look at that! This is what we captured. Isn't it cool? I mean, it's just a very rough editing. I need to say that. But either way, this is the planet we see right now. If I toss it into AutoStacked and then Registacks to sharpen it. From China, hello! I don't know Germany speaks English. Hey, Elaine, we do. I mean, not everyone, but I mean, English it's quite an international language. Okay, I have a Newtonian and an EQ3 for visual astronomy. But I want to do deep space astrophotography. I've tried capturing with my smartphone. Yeah, Toshal, I hope I pronounce it on the right way. Doing deep sky photography with a smartphone is possible. It's not that easy, but I'm going to do some videos about that in the near future because I just bought a mobile phone adapter for my telescope. So maybe consider subscribing my channel. I shamelessly ask you that, and I may do a video in the near future about this topic. I think you're gonna need a motorized mount for doing deep sky photography at the minimum, but yeah. Thanks, David. Yeah, I need to say I like it. I like it so much. The image is really cool. I mean, just for playing around for fun, I like it. This is the live view. So this is the difference. I mean, look at that. So this is the live view. You can see all the details. Okay, even if it's like blurry, okay, you can make out the details. If you look at the image closely, there are like fractions of a second where the image is clear and fractions of a second where the image is blurry. And the software does collect all the information and stack it on top of each other and just take the sharpest areas and stack only those and stuff like that, and then you do some extra sharpening, but it's not illegal editing or something like that. So I'm not adding anything, I'm just highlighting the contrasty areas, let's say. And this is what the software creates out of this live view. The difference is immense, and that made planetary astroimaging possible. The upcoming power of computers and the high speed of the digital cameras. So before that, we did astroimaging just with analog cameras, and you just could capture yeah, very blobby images. Nothing else was possible. And only with the rising of the fast digital cameras, we now can take, like, I mean, it's not Hubble-like, but it's very cool. A very cool image just with basic equipment from our backyard. I mean, the camera I'm using, it costs like 150 bucks, something like that. So it's not Hubble, even cost-wise. Yeah, it's much cheaper, but the result is cool. Yeah. And something like this was not possible without digital cameras. Okay, done. David might be gone. Bye bye. Bortle 5. But Bortle 4, Tim Yates states that he has Bortle 4.5. I'm at Bortle 4.5 too. You can image deep sky objects from Bortle 4 and Bortle 5. This is quite possible. Lucky imaging, yeah. This is the thing you do. You're taking a whole bunch of exposures, like thousands, and you're picking the best one. You let the software decide what's the best one, of course. Yeah, David, you're right. Yeah, that's big accuse that always come up when people see astrophotography images. They say, no, it's Photoshop. Yeah, yeah. No, it is not. Yeah, I mean, we need Photoshop or other programs to post-process the image just to highlight what is there. So the ethical consensus is that you don't add or delete something. This is, quote, illegal. Okay, you take the image and then you highlight what is there. And for me, I try to highlight the whole image. So not as much as certain regions, but you can have different opinions on that. Okay. Yeah, and if you do long time exposures, you can see a lot more details than just with a bare naked eye. That's just clear. Okay, we open up. I mean, our eye has an aperture of 5 millimeters. I have 15 centimeters, and I expose for 5 minutes and not for a millisecond. So obviously, I get more information about that. I did a video about stacking and the adding of information, and you can check that out on my YouTube channel if you like. And we're 12 people in the chat. Hello everyone, we're watching Jupiter right now. We watched Saturn earlier this night, and we're waiting for the moon to reappear behind the tree, and then we want to do some moon close-ups, and after that I need to go to bed because it's nearly 4 a.m. in the morning here in Germany. Yeah, I mean, if you have pics to show, like maybe David, or then just feel free to link like the Astrobin link or something like that in the chat, and the others can have a look. That's a cool thing. Someone from Canada, Honduras. We have visitors from Honduras in the chat. What cool. And Tim is from Australia. Tim, how are your skies in Australia? David is from Australia. Tim is from Tennessee. So just again, this is the result of what we captured this night. It's the stacked and slightly sharpened version. of this live view of Jupiter. Excuse me. What's crazy? It's like 3 a.m. in the morning, but it's starting to get bright again. This is summertime. It's not a good time for deep sky astrophotography because the stars are nearly gone. It's just the big two planets, Jupiter and Saturn, and the moon behind the tree. Yeah. What a cool sign. Shall we Barlow tonight? Yeah, I'm using a Barlow. This is because my focal length is not so long. I have 750mm focal length, and if I add a 3 times Barlow, which I did, then this is the result of this. 7 hours northwest of Sydney. To a Bortle 1 sky. Oh boy. I was once in Australia, and there I visited Bortle 1 sky places, and I need to tell you, Bortle 1 skies are so incredible. I was north of Cairns, in a small village in the jungle, and it was on the coastline, and we were out in the night, and it was a new moon. It was insane. It was insane. If you ever saw something like this, you know why our ancestors called thought that the night sky heaven is a half sphere, because it really looks like this. There are so many stars in the night sky at Bortle 1 skies that you can't see the star signs anymore, because it's just overwhelming. And we saw the Milky Way not as a faint and distant glow, but as a bright and shiny, structured and textured thing in the night sky, with all the curvy and wiggly extensions and the clouds and the nebula. It was amazing, and I had no camera available. It really hurts my heart because you can take such incredible images under Bortle 1 skies. David, yeah, Astrobin. Yeah, Astrobin is a great thing. Yeah, people do share their astronomy photos over there. It's a bit of a race who captures the most impressive image. It's like a bit like 8-Thought, but it's a cool thing to share the images. I mean, I upload my images to my website. I don't use Astrobin as often as I should, but it's a cool thing to do. And Elaine, thank you very much. You know what? I like streaming on YouTube, and Twitch is not really my thing. It's not about the amount of people watching me. It's about that I think it's a cool thing, and I hope you have fun here joining me in the live stream and watching the planets. And we're gonna switch to Saturn any minute soon, because the moon will take no camera. Yeah, David, I had no camera with me, really. My heart is bleeding. Astrobin is hi Mel. Astrobin is a page where you can upload your astro images and share it with other people. It's a cool thing. Just Google it. Late here, but hello. Yeah, or early here. It will be 4 a.m. in the morning where I am. Okay, shall we slew to Saturn? I say we shall. So shall we do. Where is Saturn? Oh, there! Current object. Slew. Oh no, you know what? Oh, I'm so stupid. Saturn is now across the Meridian, so the telescope needs to slew all the way around, and I really hope we find Saturn again, because the pointing accuracy of this mount is cool, but it's not that cool, okay? Maryland, slew away, yes. Okay, let's hope we find Saturn again. Okay. Okay. We need to wait a few minutes. Yeah, Elaine, this is true for all EQ mounts. Because I know we lost Saturn, whatever. It's true for all EQ mounts because where am I? There, over there. The counterweight never must be above the telescope for safety reasons. And so you're tracking the night sky until the meridian, and then your counterweight is like on the same height. And then you're switching side. This is called meridian flip, and then you can keep on tracking the night sky, okay? But this flip needs to be done for whenever an object crosses the meridian. Then you need to slew all the way around on the other side, and you can keep track on the object. Yeah, why not? Feel free to link, David. Why not? So we need to wait until Saturn is past the meridian. See whether this works. Yeah, now it's past the meridian. Telescope just got stuck within the meridian. Yeah, now the problem is that we lost Saturn and we need to find it. Yeah, and so I'm telling my telescope to systematically scan the night sky for signs of Saturn. And maybe we're lucky, and maybe we're not lucky. So the pointing accuracy is great, but I'm using a 3x Barlow. So the field of view is very, very tiny, and Saturn is very, very tiny. So even if we missed Saturn just by a few degrees, so that would be a problem for us. Maybe I can re-slew to Saturn. And really, all I can do is guessing around. And if we're not lucky, we we can't find it. This is a pity. I can switch the cameras to my guiding camera. Maybe we have more like here. I mean, what's that? Is that Saturn over there? Oh, look at that. I think I saw Saturn. Thing is, the guide cam does have a much, yeah, this might be Saturn, has a much wider field of view, and we can use that because I aligned the cameras. I mean, not perfectly, but now we know that we are somewhat close. And then we can use the smallest amount of... Sorry guys, I can't read the comments right now, because I need to find our beloved planet. It's somewhere around here, but this is the problem with such a long focal length and such a tiny field of view, such a dim and tiny planet. But maybe we're lucky. Maybe. Okay. Thing here. Maybe I do like 2 times binning. Bring down the exposure. Right, Tong, thank you very much. Yeah, the coffee is very much appreciated. Back in 5 minutes. Can you plate solve with a guiding cam? Yeah, I can do that, but the problem is that my main cam and my guiding cam is not perfectly aligned. And so I found Saturn. I mean, look at that. It's right here. Okay. Like here. Thing is, I don't know where my main camera, so this is the main camera, where it's pointing. So as long as I don't know that, it's a bit of pain in the to find that. And Tong again, thanks for the 500 yuan. Coffee is very much appreciated. It's 4 a.m. in the morning. Okay. Here we try to find Saturn. Over there. Over there. Oh, look at that. We were lucky. Alright, reverse. Yeah. Okay. Look at that. That was pure luck. Okay. It wasn't my fault we found that. This is sometimes it's a problem. Second thing is Saturn is now on its head. It's reversed. Oh, look at that! What an amazing view! Oh, boys and girls, look at that! Oh, I love it! I love it! The viewing is quite good this evening. So I'm staying here and yeah, taking some more images of Saturn. Thanks, Tom. Ah, this is a cool sight. I love it. As I told you, Saturn is just such a beautiful planet. Really cool. Look at that. You can see the rings. You can see the Divinicus division. This is a gap between the rings. You can clearly see different cloud structures. And yes, after we saw Saturn right now, we're gonna slew to the moon because I look up and I see that the moon cleared the tree finally. But I think it was worth all the effort finding Saturn again because it's just such an amazing planet and it's such a beautiful thing. Yeah, and if you can see the cloud structures right in the raw video format, in the live view, this is a good sign. Okay, so this normally means that that the seeing is good, and seeing this Cassini division, at least from my backyard, okay, this is normally a good sign too. Okay, you see the sky behind me gets brighter and brighter, even being not even 4 a.m. in the morning. It's insane. So deep space astrophotography is gone by now. But we're gonna capture a few more images of Saturn, and then we're gonna switch to the moon because I promised you. Really, I love the view of Saturn. It's so cool. Yeah, there are different band colors in Saturn that you can spot. It's not that detailed and rich and swirly and stuff like Jupiter. I mean, Jupiter's texture is so rich and so dynamic, but Saturn has different brownish bands. That is cool too, and the rings, of course, the beautiful rings. And you can actually see and spot the difference. I imaged Jupiter last year and the year before last year, and the angles of planes between Earth and Saturn changed. So now the from our perspective, lower edge of Jupiter is way above the ring, and when I imaged Jupiter 2 years ago, Saturn 2 years ago, we saw it like face on, not really, but the angle was another. So you can compare images of Saturn from different years and see how the plane tilting is shifting. This is quite interesting. So we captured 1,500 frames. I want to capture 2,000. And then it's okay. Yeah, Mel, me too. Traveling there would be so nice. So nice. Or we can travel there in our thoughts. And we can view this magnificent planet, this beautiful marble in the night sky. It's so beautiful. So SharpCup is nearly done taking the images of Saturn. We are collecting a huge bunch of images and we're stacking them in post-processing, but not this evening. Because in the not too distant future I need to go to bed. Because it's really late. And how long is this stream? I don't know. Stream. 2 hours. Whoa, we are 2 hours into the stream. And I love it. I love it. I want to thank you all for being here, for sticking around with me, and having a time with me. I really like this streaming, this live streaming. It's a cool thing. And now SharpClip's done. We say goodbye and good evening to Saturn and slew over to the moon. Shall we? What do you think? Let me know. Shall we see the craters and rims of the moon or not? I'm back again. Okay, let's It's really early. Yeah, it's really early for me, or late. I don't know. I can't decide. Okay, let's do it. Okay, let's do it. Let's do it, let's do it, let's do it. Once again, because the moon is on the other side from our sector of the meridian, we need to... You can actually see my scope there, right there. And you see it's doing its thing. And we're gonna need to search the moon as well, but it's so bright and so big, so I think we are not gonna miss it. Either way, I'm a game. Please, moon. Yeah, we do so. Okay. It's still slewing. You know, the EQ6R Pro is so quiet. It's such a quiet mount. It's really a great thing to have a quiet mount if you're imaging in the neighborhood, because my EQ3 Pro, that was such a noisy mount. It was unbelievable. It was so... Wow. No. We had a sneak peek. Now we need to find it again. Wait a sec. Okay, where's my controlling? Right over here. Hello? Okay. You see that? That means we're way too bright, way too bright. We need to crank it down. Like, wow, the moon is so bright. Look at that, boys and girls. What a sight. I am quite excited. Moon! Ah. There it is. Okay, so I need my controls over here. I'm gonna control it from here. And I need to reverse RA. No, I need to reverse deck. Okay. I need to crank down the slewing speed. So this is the moon. It's quite a bit reddish. And the focus is not perfect. And the seeing is not perfect. But where's... But it's good enough, I think. Let's say whether we can nail focus one more time. Must not step onto any cables down there. The cable management is not the best. Okay, let me have a look. Focus was well within what's possible for tonight seeing conditions. That's okay. You know what? I think... Yeah, Tim, let's take the Barlow out. Now we need to refocus again, because why not? Yeah. This is as good as it gets this night. And you know what? I like it. I like it this way. Okay, so we see those whitish craters like here. Decrease the slewing speed. And within these craters, you see the impact material being spit all over the moon. This is always a cool sight. The difference between the brighter side. There are very big craters there. I can't name them all, so this is not naming all the craters is not my thing. So, and down here we get to the terminator. This is the edge between the darkness of the moon and the bright side of the moon. Yeah, the magnification, David. This is compared to what? Compared with my normal eye? I mean, if I scale up the image, is the magnification higher or lower? I think with astro imaging, there's nothing like magnification or something like that. And those areas near the terminator line, they're like very, very beautiful to look at. Hey, David. What is... It's like the moon has an atmosphere, yeah. Asteroids. Can you tell us the magnification? I don't know. I know. So I use a native focal length of 750 millimeter, and I'm using a very small camera. So, but I don't know what magnification corresponds to that. So, if you are on visual astronomy, then magnification can be calculated by dividing the focal length of your telescope by the focal length of your eyepiece. And this is just compared to your normal field of view with your normal eyes, with your eyes without any telescope or binoculars or stuff. But with an astrophotography, because it depends on the sensor size and the focal length, and you're talking about field of view, and we're covering like something of like a half a degree in the night sky. What a beautiful sight. Look at that. Maybe we take an image of that. 2,000 frames of that. Oh, you know what? We are cropped. We are still cropped, so this is not even then the biggest image we can get from the moon. Stop capturing. Okay. Look at that. This is beautiful. Oh, boys and girls. This is cool. I like that. We capture 2,000 frames from that. It's much more marvelous. Look, yeah. Oh. The moon is something beautiful too. It's very relaxing to view the moon. It looks very sharp this night. I mean, it's not really nice. It's an hour to go and it's bright daylight. I can image the sun, but we won't do that this time. I'm really exhausted. It was so much fun, but I'm really tired. And go full frame, yeah. Okay. Yeah, we are full frame now. So I could get out my DSLR, but that would take ages to attach. And then we could fit the whole moon into one image. This is what I did with my live stream from last time. I live streamed the solar eclipse, and that was a cool thing. And I used my DSLR because I could fit all this in the entirety of the sun into one frame. It's beautiful. You know, I'm looking right in this direction. There's my beautiful little moon, and on this screen it's so big. Look at that. Look at that. That's a cool thing to observe. Yeah. This is roughly the amount of sky I can cover with this tiny camera, because this is only a camera I normally use for planetary imaging. So if I want to take a full frame image of the moon, I use my DSLR, or I do a mosaic, and this works just fine. So you take different images from different parts of the moon and then you stitch them together. And this is really cool. Yeah. Mew says the moon looks peaceful always to me, but then you see the craters and there was a lot of action there. Yeah, but spread over millennia, yeah, over the last, since the beginning of our solar system. So those craters are ancient, and the odds of getting hit, I mean the Apollo astronauts on the moon, there was no risk getting hit from an asteroid, because it's very rarely, it's just the immense amount of time that adds up all the craters and the lack of atmosphere and the lack of erosion, and so all the craters since the beginning of the forming of the moon are still well preserved. So Zachary Bennett asks, thoughts on visual astronomy versus digital imaging. Yeah, I'm team imaging. Only I have 2 eyepieces, but I don't use them because really, why? The view through my telescope using that camera is just so fantastic. I really love it. And you know what, folks? Having seen the moon and its beauty, and having spent like 2.5 hours with you folks here with my telescope in the night, it was a really cool experience. I really liked it. I hope you like this video. Hit like, hit subscribe if you like. And I want to do some sessions like that in the near future. I will give you notifications on Twitter, so please feel free to follow me on Twitter so that you don't miss any live streams, or hit the notification bell and you get notified. I think it's a cool thing. If it's night where I live, then most of you folks are in the US, so it's evening at your position. Some of you folks were from China and Australia, so it's morning again. It's a good compromise, I think. So living in the middle in Europe and Germany gives me a good a good time actually to stream that for you folks. And yeah, I want to do something like that in the future. Maybe do some planetary astro imaging as well, but I really like to do some deep space astro imaging live sessions with you. So that would be that we sit together, I attach my astro modified DSLR to my telescope, and then we vote in the channel, in the chat, for the next target, and we are not imaging the target properly. It's like we're just spending a few cool moments at one target, gazing at the beauty of the night sky, and after that we slew to the next target, and we're just target hopping, and we can do a star party. I think that would be a great idea. You can leave your thoughts and comments down in the chat below whether you like to see something like that. And that would be an upcoming project of mine. And so the live telescope sessions, this is the first one. That was a cool one, and I'd really love to improve on that and do something like that in the upcoming future to have more sessions like that to come. Yeah, you're very, very welcome. Star Party sounds fun to me too. I hope we can do something like that, and that would be a cool thing. Yeah, look at the moon. This is the final shot of the moon. You won't slew anywhere else. We had Jupiter, we had Saturn. This was the result of of Jupiter. That was the image we took an hour ago, and we took some great images of Saturn, and we have a marvelous view on the moon. And now the birds are coming up and start singing, and everything is quite peaceful. But actually, folks, I'm quite tired, so um, it's lunchtime for David, as it's early morning for me. And I think with all that said, and with all that imaged, and after 2.5 hours, I think we're gonna quit that stream and call that a night. What a night it was. What a night it was. Cool. Thank you all for being here. Thank you all for staying with me, for chatting along with me. It was a cool thing. I really enjoyed it. And have a nice day. Have a nice week. Have clear skies. And yeah, there you go. Bye bye.